Welcome, everyone. Oops, sorry about that. Welcome to our Generative AI Innovation Incubator. This is the opening keynote session. We have around 1,000 people registered across a variety of events that we'll offer over the summer. And the hope is that this grows into something more persistent, where we can bring communities together to be considering what the future of generative AI should be and how we can work towards that future together. So thank you so much for your interest and for coming today. And we're very excited to have Tom Mitchell here, one of the founders of the field of machine learning, who's going to be really just starting the discussion. And so I would like this entire endeavor to be very interactive and conversation focused. And because of that, Tom has requested to do this keynote as kind of a discussion. And so it'll be conversational both between the two of us and the audience. And in the end, we will have a mixer where you'll have the opportunity to meet each other. And you'll see how it is that over the activities that we plan to have as part of this, the idea is to get you guys to know each other. This is a worldwide community of people considering issues that are important to all of us and how these recent advances change our lives. If you look out into the media, you can see a lot of hype and fear that I think that we mainly agree is not very productive. And so one of our goals in this endeavor is to counter that with vision and ingenuity as we work together through panels, invited talks, tutorials, and hackathons that begin with discussion and exposure to the issues, include, especially through the tutorials for the summer, education, but we also plan to actually develop a full generative AI certificate with the hope of being able to launch that sometime in the next year. And also hackathons where you can partner with others, design projects, and compete for cash prizes that would support developing the prototype that is built through the hackathon into a real end user application in this space. And that will be sponsored by the Block Center. So we're focusing on 3 areas of impact throughout this entire summer: education and the future of work, medicine and public health, and finance and economics. And we'll have talks and panels on these topics, as well as a hackathon in each one of these areas that will give you the opportunity to come in and actually do hands-on work in this space. So today we're very proud that Dr. Tom Mitchell will be our keynote speaker. He's a Founders University professor of Carnegie Mellon University, founder and former chair of the world's first machine learning department. I'm very proud that that's in our very own School of Computer Science. He was the interim dean of the School of Computer Science from 2018 to 2019. And I can personally say I was extremely excited when I heard it was going to be Tom. I just felt completely secure knowing that he was our dean during that interim period. He's an elected member of the U.S. National Academy of Engineering, an elected member of the American Academy of Arts and Sciences, and a fellow and past president of the Association for the Advancement of Artificial Intelligence. I just want to give a little highlight that next week we will also have a keynote talk that will be from Roni Rosenfeld, who's the current chair of Carnegie Mellon's machine learning department. He's a professor of machine learning, language technologies, computer science, and computational biology, and co-founder and leader of the Delphi Research Group. After his keynote talk next week will also be an Ask Me Anything panel featuring fellows from the AAAS Leshner Leadership Institute for Public Engagement with Science. Even since you have all signed up to be part of this summer of events, we've added additional ones to our evolving schedule, including an invited talk by Manuela Veloso in the area of finance and generative AI, so you won't want to miss that. So keep your eye on the website. And now, go Tom.
Well, it's great to be here. Thank you, Carolyn, for the intro. I think if we have a conversation, I'll let you drive.
Okay, great. I think we're going to start out with a series of questions revolving around what are the real capabilities of generative AI. I think I've alluded to hype and fear in the media that I think refers to things that to be honest, are probably outside of the scope of what generative AI is currently capable of. Why don't you start out with just kind of a general, how would you, from your longtime experience in the field of AI, characterize what are these recent advances and kind of what are the boundaries of capabilities there?
Well, I think one way to look at it is how did we get here? And we got here over a 70-year period, 60-year period of research in AI, where for a long time, people proceeded trying to build intelligent systems the way they tried to build other computer programs, which was to write them manually line by line. But it turned out that there are many kinds of intelligence that we have that we can't really articulate how to do it. Like we can all recognize our mother in a photograph, but I've never met a person who can write a computer program to recognize their mother in a photograph. So starting seriously around the late 80s, machine learning became an alternative to writing these things by hand. And that took decades to develop. But I would say the first commercial applications, things like credit card fraud detection, occurred in the early 90s. Around 2010, 2012, there was a huge burst of progress from the appearance of deep neural networks, which were like earlier neural networks, but more complex, and were trained from much more data than we had access to in the 1990s, and which used computers which were incredibly faster and more powerful. So then during the 2010s, there was kind of gradual progress. But I would say around 2017, 2018, there really was a big change, especially in the field of natural language. And it occurred because people started realizing that instead of manually labeling data, like labeling this picture is my mother, this picture is not my mother, instead we could simply take all the text on the web and without manually labeling it, just train a program to predict the next word, given the words that occurred so far. And even though nobody really wanted a program to predict the next word, you could get trillions of data examples like that. And people had a hunch it would be useful. Well, it turned out to be way more useful than most of us thought, because systems like GPT, Google systems, Meta systems, all of these large language models now are trained literally to predict the next word in the text sequence. But as a side effect of learning to do that, these systems are forced to come up with an internal representation of what those previous words really meant. Because the only way really to predict the next word is to know what those earlier words meant. And it turns out that all of us were surprised, including the people at OpenAI who developed the system, have been surprised at the capabilities that emerge once you train a system to have that kind of representation of meaning of language.
What does that mean that is really being learned about meaning? What would it even mean to represent meaning?
It's a great question, and I haven't met a single person who has a good answer to how to define meaning representation. I will tell you that I've spent a lot of my career looking at the human brain with brain image data and trying to decode from somebody's brain activity which word or which sentence they're thinking about. And we've found remarkable things about the brain in this way. For example, we could train a program to decode which word I'm thinking about by showing it examples. And then we could use it to decode what you're thinking about, because apparently humans have very similar neural codes for meaning of words. So now we can do that sort of thing, but we still don't have an answer to what it means to represent meaning. We just know, here's an example. It's this pattern of neural activity in the brain that represents computer versus airplane versus celery. And it's the same thing in these artificial neural networks. In these large language models, which have hundreds of billions of connections and approximately that many activations in their artificial neural systems, there exist meanings of words, meanings of phrases, meanings of sentences. And all we can say is there they are, just like the brain. It's a pattern of activations across many, many different neurons. In the brain, they're biological. In the computer, they're silicon. But still, all we can do is say, somehow that meaning is captured by this vector, this huge high-dimensional vector of activity.
So you mentioned lots of concrete objects that you can learn how to detect the neural activity that represents that somebody's thinking about that object. Do you think that extends to meaning of all kinds of words?
We don't know, to be honest. I will tell you that when we were studying the brain, we tried, once we found that we could decode which noun you were thinking about, we thought, well, the next obvious thing, let's do verbs. And we found we could not. In fact, we could not yet, if we give you a verb like cut or heal, we could not get a person's brain activity to look the same each time we presented the verb heal to them. And so we found there's something different about verbs. Later on, we found out that if we paired the verb with a noun, if we said surgeons cut and surgeons heal, then we could tell which verb it was. But if it's a floating verb, it was like it really didn't quite have a meaning until there was an agent and perhaps a patient along with it. So what it means then to take a sentence like the one that I'm saying right now and figure out what the meaning representation of this very long sentence really is at minimum problematic.
So we're already at problematic when we go from a word to a phrase. How do you account for how the way a word comes across depends upon who said it, where you are, what's going on around you? Then it seems like meaning doesn't necessarily live just in the text.
Yes.
So then how does that cause problems for this idea that intelligence is emerging from learning of sequences of words?
That's a great point. It's certainly true that context matters in many ways. Depends on the tone of your voice. It depends on where we're standing. If we're standing next to the river and I say, oh, look at the bank, you think it's a geological feature. If we're standing downtown and I say, look at the bank, you probably think I mean a financial institution. So there can be all kinds of context that influences these meanings. But if you think about it, how are these systems like GPT trained? They're trained really on text. And text, as humans, we've become very good at creating text that avoids some of the inherent ambiguity that might be if we were in a genuine, rich context and speaking. And so when we write text, we kind of subconsciously, I think, try to get rid of a lot of that ambiguity.
What about the fact that there are sort of cultural meanings of certain things, where a culture can be as big as a whole ethnic group, or as small as a family, or even just an individual relationship? And in those contexts, there are meanings of phrases and words that trigger associations that aren't going to be part of any given corpus that a language model might be trained on. So does that mean that those aspects of how we use language to get things done in our social environment are going to be beyond the capabilities of language models?
You know,
Could they be reachable?
It's easy to think that that would be a shortcoming. But then if you think about how these things are trained, right, they're trained to predict the next word given the entire history of words up till now. And so these contexts are kind of reflected and in that sequence of words. And even things like cultural differences might be reflected if, for example, culture A uses a certain kind of vocabulary to talk about things and culture B uses a different vocabulary, then that'll show up in the context. And one thing about these models, these large language models, is they're trained on very large volume of text, and they're trained for literally months on supercomputers so that they really are pushed to squeeze as much information as possible out of this context to get the right prediction for the next word.
So even if it's possible that in absorbing all of this text, that it really is able to separate out these contexts, which I'm not entirely convinced of, do you find that just because of practices in what gets written down versus what is considered not necessarily important to write down ever, that there would be gaps in what would be learned that would change fundamentally how language is processed, and let's get eventually into how reasoning happens.
Yes, yes. So surely it's possible to miss these things. One interesting thing that's happening is the next generation of these large language models, we're going to have to come up with a different name because it won't be just language.
That's true.
It'll be a large model that's trained on language and on video. So for example, Google has not announced any plans, but if you were Google and you had YouTube as one of your assets, if I'll just say without attributing anything to Google, if I was in charge of Google and we had YouTube, I would say, let's start training a system that uses all of the text on the web, plus all of YouTube, so that we predict not only the next word, but the next image, the next sound, whether or not somebody's going to speak at all in the next image or not, ambient sounds as well as speech. So that becomes much more multimodal set of information, and it captures some of the issues you're getting at.
What about, it seems like threats, for example, are a very particular usage of language that requires very detailed knowledge from one person to the other person. Like what subtle thing could you say to that person that would remind them of something? Because they're rarely on the record. Could one of these GPT models learn how to effectively make threats like that? I mean, obviously, very overt threats are not so hard to learn, but maybe like the subtle ones.
The subtle
just
ones.
Remind you of something.
Well, I'm sure in the large volume of web data that it has been trained on, there are examples of very direct threats. For example, in fictional stories, that kind of thing happens. And, you know, in that sense, these models probably have an ability to generate those kinds of utterances as well as others. The subtlety with which people can do it is pretty remarkable. I haven't tested, but I would be surprised if these systems were as good as people at making subtle threats.
I think that one issue is that I wonder what you think about the fact that models learn patterns. They put more confidence on patterns that happen more frequently. And so there's kind of a reliance to one extent or another that the important things that you wanted to learn happen frequently. But when it comes to something like a threat, they are usually very infrequent. So then how would you expect that a model could learn to separate those infrequent but really important things from noise?
It's kind of interesting to think about what it means to be an important thing. If one of the things it means when it's important is that it has a strong influence about what happens in the future, then the systems, because they're trying to predict the next word, will kind of automatically have to assign greater significance to those important things, those things that really do influence what the next word is, as opposed to the unimportant things which just happen to be true, but not really very significant in terms of the future outcomes. So that's kind of, that simple notion of importance is kind of built in. The other thing I'll say about these models is, even though it is very true that they're trained to predict the next word, they do that successively. And so if you actually work out the mathematics of it, it turns out to be pretty much equivalent to learning to predict not just the next word, but the whole next sentence or the next whole paragraph. And so that makes it a little easier to think about how on earth could they be so capable despite this simple kind of training. So
here's something that I often think about when it comes to chatbots in particular, that training a chatbot is, you could reduce it down to predicting what the next turn should be from what you have seen so far. So obviously humans are not able to do that, because if we were able to do that perfectly, there'd be no point in having a conversation. So then where do you think that leaves us in terms of how human-like or not would a chatbot ever be able to be? So if it's learning what it should do next based on the most frequent thing, which isn't really what happens in a conversation, then how does that place limits on how natural these interactions can ever become?
So, it's interesting. These systems are really, they're used, or some of them are used in chatbots. But the training is not in the context of predicting what the other person is going to say. It's predicting what this text is, right? And the way they're used is that the model is used to predict how it should respond given the conversation so far. But then it just waits to see what you actually do say. It's not really predicting the other person's response, right? And so there is still a need to have a conversation with it, because it doesn't know what you're going to say. It only knows what, the probability distribution over words on the web looks like. And so, conversation is still a genuine exchange of information in that case.
So beyond the genuine exchange of information, there's this idea of intentionality, that in our interactions, I have goals and I'm trying to accomplish something in the choices that I make, how I respond to you in the conversation. Where does intentionality come from learning sequences?
This is a really interesting fundamental question for which we don't have an answer. If you play with these chatbots, you do notice that if you say, I'm trying to study for my exam tonight, you tell it your intention. And then you say things like, and I've got a class from noon till 1. I will have about an hour afterwards. What should I do? It will give an answer, often a very reasonable answer, that some people, as outside of observers of this black box, might say, it understood your intention, otherwise it couldn't have generated that. But We don't know. That's like saying the thermostat on the wall understood you were cold, and therefore it turned on the furnace. Maybe from an outsider's perspective, that's a way to attribute a description of the behavior, but it's not necessarily the mechanism that's generating the behavior.
So what I'm noticing as a pattern in your answers to these questions is you're framing something like ChatGPT or maybe GPT models in general, usages of language models in terms of them understanding what you're trying to get and giving it to you. But intelligent behavior isn't all about being a source of something that people come and ask for and you give it to them. There are other ways that we take agency in the world. Do you believe that the main capabilities of these GPT models is really as you framed it, that they are information sources that you can come to with a request and it framed in some particular form and get what you've asked for, and leaving out all other aspects of intelligent behavior? I think that that's a question that's really important to a lot of people who make claims like these GPT models are self-aware, general AI, it's going to be, they imagine that intelligence goes beyond just an information source. So what do you think about that? How do you frame the idea of what is this intelligence?
I guess I really do think of it as generating text in response to what has come before. And if what has come before is a conversation, then that's, in the conversations I have with the system, it's primarily me saying, here's what I want to talk about. Here's what I'm trying to do. Help me solve this problem. It does not, in my experience, say, no, here's what I want to do.
Right.
So that is the way that I think of it at the moment. It is clear that it has very sophisticated representations of the meaning of what came before. And that does include things like my intentions. But because we don't really have the ability to put those representations under the microscope and understand them, the only way we can study them is give them stimuli and see what they do. It's almost as bad as trying to study humans, where the only thing we can really do is give them stimuli and see what they do.
On the other hand, that's like casting people like lab rats, right?
Which psychology has done for many years.
That's true. But in the world, our interactions with people are not always as scientists studying how people behave. So I do think that it's interesting to think about the roles that we expect this technology to play, because as I listen to a lot that's in the media and people reading that and listening to that and thinking about what that's going to mean for the world, there is a lot of imagining roles for this that go beyond source of information.
Right.
And so it would be good to be able to kind of like define the boundaries around what we really expect, because I think as computer scientists and especially as AI researchers, we kind of understand that we talk about these things in very loose, informal ways because we understand the limitations. We don't feel that we have to make them explicit, but I don't know that that's coming across. And I wonder if that is something that we should be concerned about in terms of the impression that it gives and the reactions that it triggers.
Yeah, I think it's worth talking about what are the real capabilities of this stuff today and where's that headed. So maybe spend a little time on that. So I bet everybody in the audience has already had a conversation with ChatGPT and probably several other systems by now. To me, the way I think of the system in terms of what's how big a deal is this? The way I think of it is, yes, it's a big deal. And the reason it's a big deal is for the first time, we have a system that has mastered the grammar of language. I've never seen GPT make a grammatical error. Sometimes it says stupid stuff, false stuff, but I've never seen it make a grammatical error. It has mastered the grammar of language. Now that alone is pretty interesting. It's also, it has also some abilities to reason. I gave it a simple question. Let's do this example. I said, I bought 2 boxes of eggs. Each one had a dozen eggs. For breakfast, I opened 1 box and ate 2 of the eggs. How many eggs do I have? And it says, well, you have 22 eggs. 1 box you didn't open, that still has 12. The other you ate 2 of the eggs. Then I said, then I gave it the same problem, except I said, I opened 1 box and I painted 2 of the eggs. And it said, well, you have 24 eggs. Now you have 22 without paint on them and 2 with paint on them. Now think about that. What that means is that it knows the verb eat means it went away. And that the way to deal with went away is subtraction. It actually gave me the equation. And it knew that paint meant change, but don't subtract.
Unless it's one of those like painting of eggs that you suck the egg out before you actually paint it.
I did not specify. I did not specify. So let's keep going. So then I went back to the original one where I ate the 2 eggs. And I said, suppose I had a student and I gave them that word arithmetic problem and the student answered it incorrectly. What would be a good hint? And it gave me a good hint. It said, you might suggest to the student that they focus on the box that was open and think about how many eggs remain in that box. And if they're still stuck, point out that the box that wasn't opened probably still has the same number of eggs. So why am I bringing this example up? Because to me, it illustrates a kind of sophistication in reasoning and a sophistication in understanding what it means. Oh, when I asked for the hint, I said, but don't give away the answer. And so it understood what it meant to come up with a hint that did not give away the answer, but would help. And I've done this for a number of word problems, and I get this kind of response from the system. So back to the original point, the system is a natural language grammar expert. It also has a lot of common sense. It knows the difference between painting an egg and eating an egg in terms of subtraction or not. And it has reasoning abilities and some kind of, I don't know if you want to call it reflection ability, but some kind of ability to understand what it means to give a hint that won't give away the answer. So those are kind of the capabilities we have today. What does it mean? I think it's very fundamental change, because if you think, one way I think of it is this: think of the evolution of writing and reading. So when language was generated, that was a good thing. We could communicate. When written language was generated, that was a good thing because we could communicate even with people who weren't together with us at the same time. We could just write it down. Somebody else could read it. That was good. We got the printing press. That was good. We got the World Wide Web. That was good. That meant everybody had a printing press. And I think this is just as significant because what this does is it means every document or every library, which used to be a monologue, right? A document is a monologue. The person writes it, it's not a conversation, it's a monologue. Now every document becomes a conversation. And if it's a short document, it might be not a very interesting conversation. But if it's Wikipedia, that's a pretty interesting conversation you could have with Wikipedia. And you can. And now we see spin-offs. We see companies like Chat PDF where you begin the conversation by uploading a PDF file. And then you have a conversation about that paper or whatever that document was about. So one way I think about the significance is it's bringing us to a world where every document can become a conversation and every library can become a conversation. And the implications of that are huge, especially because not only can it become a conversation, but the first step of the conversation can be, please summarize this document or this library in 2 paragraphs for me. So it can do summarization at a level way beyond what we had before. It can converse about the content of text at a level we never could before. And now we're adding new capabilities too, because, you know, very recently, the idea of plugins, which simply means that you can easily tell GPT how to use a separate computer program. When ChatGPT first came out, one of the things people notice is it's horrible at arithmetic. If you give it a complex addition problem or multiplication problem, it'll be wrong. Although it'll be very confident when it answers. But now it's easy to say, here's something called a calculator. And literally you say in English, calculators can multiply numbers. The way you call this calculator is you put left bracket, calculator, right bracket, number, symbol, number, and right bracket. And it will return the number. So now we're giving it additional abilities to invoke these other much more capable, but much more narrow systems like calculators, Google Maps, optimization methods that people use for solving inventory control problems. These will become subroutines that these models will be able to use. And we will still have the benefit of natural language interface to it, and the benefit of its ability to do, somewhat competent reasoning and common sense understanding of what we're really trying to do. So when you put that all together, I think it's very significant. It's going to, people have already noticed, for example, that it will probably have a huge impact on personal education. If you watch Sal Khan's recent 15-minute TED Talk, which is fantastic, great talk, he kind of sketches out a prototype system that they're working on at Khan Academy. It's also going to have a big impact on medicine because it can, again, summarize and bring together a lot of information from disparate sources. Eric Horvitz, for example, has a paper recently about how this will impact the medical field in particular. So we're going to see a lot of this stuff happening. One thing I don't see people talking about, but I think is really highly likely and highly significant, is we will have, I think, personal assistants like we've never seen before. We will basically, well, here's the idea. It's not hard. Actually, let me back up. Suppose you wanted to build a personal assistant out of one of these. If you want to specialize it, you actually have 2 alternative choices. One is you can train it more by giving it more data and changing the values, all of those hundreds of billions of parameters. And you better have a big computer if you're going to do that, but that's one of the ways. The other way is you can just start your conversation by giving it a 100-page book to read. And instead of changing the weights in the system, you've now primed the conversation with a lot of reading. And even the current versions of GPT-4, the prompt you give them can be up to roughly 100-page book. Now people are coming up with even larger contexts. So if you want to build a personal version of this, you could basically give it your bio. You could give it your calendar. You could give it, I don't know, the most recent year and a half of email. You could give it all of the papers you've ever written, your memos and communications, and then you could begin the conversation. It'll know about you. It'll be able to, and notice to do that, you don't have to retrain it. All you have to do is get the server to keep track of your profile. And now it'll know you and have a conversation. And why would you want that? Well, because it'll be able to help you if you give it access, for example, to your bank account. Help you with the family finances, help you really manage the chronic health issue that somebody in your family has. Essentially, it will give each of us as individuals the kind of team of assistants that CEOs can afford. CEOs have a whole team of people who summarize information for them, provide a briefing. The CEO makes the final decisions for the company, but there's a lot of support staff giving advice. We're going to end up, every person is going to end up, I think, like a CEO in that sense. We'll still have to make the final decisions, but we're going to get a lot of support and advice from the system.
Let's go back to what you were saying about math, just as the foundation for the idea of how much reasoning is actually going on. So that was a very compelling example that you gave about the math problem. I guess one question, I think there are two interesting directions in here for me. One of them is, what would it take to ground whether it's really reasoning or whether it's drawing from some textbook pedagogy design examples where eggs might be an example that's been used frequently, so if you did something much more unusual, would it still be able to do that? That would be one question. And my other question, I think, goes back to, I don't know if you've heard of the studies of coconut math. It's a famous study. Lauren Resnick and some of the others at the Institute for Learning were involved in this research in the past, where they've gone into villages where their education system isn't as kind of abstracted and formalized as what would be typical for a student in the United States in terms of their math progression. So you mentioned, for example, that it seemed like it was able to do this very sophisticated mathematical reasoning from a story problem, but that it might not be able to do that in a kind of more abstract, symbolized version of some complex arithmetic, if that's complex, something that would be very simple for a human, right? It can do one thing, maybe it can, and it seems to be reasoning at a very deep level about the math and how you would even teach it, versus can you do arithmetic, which, any math teacher can do arithmetic, but, if they're not a good math teacher, might not have good ideas about how to teach it, especially without giving an answer away. Some people would argue that there's a way that we can understand math in a contextualized way, because we've seen how it plays out in that context. And so if you're used to seeing people eat eggs, you understand that when you eat them and eventually they're all gone. And so you might be able to answer the question not by first translating it into its symbolized form and solving it, but because of your experience. And so I wonder whether that suggests that because language models are learning what they're able to do that looks like reasoning from text, which could be seen as their equivalent of experience, that all of the mathematical reasoning that they're doing is really of the variety I'm used to seeing this happen, and this is more consistent with my experience versus actually an abstraction of the math that from explicitly taught math.
That's interesting. So let me tell you one more thing I did with the egg problem. After I said about 2 boxes of eggs, I ate 2, how many are left? Another thing I said was rewrite this problem as a problem that involves the Pittsburgh Steelers. And it said, okay, the Pittsburgh Steelers training camp bought 2 bags of footballs. Each bag had 12 footballs. Before they started the preseason practice, they gave away 2 footballs from one of the bags to a local high school. How many footballs do they have?
That's cute.
Okay,
But it's very, very similar. It's surface,
it's
though,
on the
right?
veneer, right. It's on the.
But it is creative. It sounds creative.
Well, okay, then I have to tell you one more story. I also there's a well-known problem in math world. Mary drove from point A to point B at 60 miles an hour, while Bill drove from B to A at 30 miles an hour. They both left at the same time. Do their paths cross, and if so, where?
Mhm.
Okay. GPT-4 answered this question correctly. They meet 2/3 of the way. You told me the equation, the whole thing. And then I said, well, what would be a good if a student says they meet in the middle? And it said, well, if they meet in the middle, you should point out to the student they will have traveled the same distance. And does that really make sense, given that they're traveling different speeds? Which I thought was pretty good. Then I said, rewrite that hint as a Shania Twain song.
No.
And it did the most amazing job. It turned it into a song where the chorus was literally there. And then there was another verse in the chorus again. So again, it surprised me in its ability to move pretty fluidly between the grounding of a word problem and the abstract notion of what was the math involved in it. Again, that's, as you were pointing out, that might be another problem where there are plenty of examples on the web, and therefore in its training data, these kind of travel in 2-direction problem questions, because that's another popular question in primary school algebra.
Yeah, that's true. There are even memes about that. So. Okay, so let's move into societal implications, both positive and negative. What do you think are the greatest opportunities for human impact? I mean, you've mentioned some example applications, but what do you really hope will happen, and what do you really hope will not happen?
Yeah. So I think 2 areas where not just me, but many people think there's a big opportunity are healthcare and education are 2 of the applications. I think we have a good chance, but I'm also aware that, for example, in our healthcare system, there are many non-technical reasons why we don't use AI already more than we do. And I've been involved in multiple meetings at the National Academies of Medicine about the adoption of AI in medicine. And both of the 2 most recent meetings I was involved in, the unanimous consensus at the end was, oh, there's plenty that we could do with the technology we already have, but the incentive structure is wrong. And that's why it's not being adopted. So I think there's a lot that can be done there. There's a tremendous amount that can be done in education. I know that's an area that you look at a lot. Partly because these systems can really converse with you and at some level understand, what problem you're trying to solve, discuss with you where you're stuck, suggest sub-problems for you to look at and that sort of thing. And again, the Salcon video is a great 15-minute investment to kind of see what some of the vision of that future looks like. In education, I worry also. Actually, I think the opportunity is huge. However, there's concern by some people that this will replace teachers. This will not replace teachers. Teachers are the reason why kids learn in many cases. So it's not going to replace teachers, but what it will do is when you have a teacher with 25 students in the class, now it's going to be a teacher with 25 students and 25 personal teaching assistants. And when that kid goes home at night to do their homework, the teaching assistant is still with the kid. And it'll be a much more enriching experience when they do their homework at night. It won't be, here's this list of 10 questions I made up before I knew whether you understood the material or not. It'll be, well, here's the first question. Can you answer it? And if you can, we'll give you question 2. If you don't, let's discuss what you need to understand to answer question 1. And then let's maybe do a different question 2. And let's have a conversation. So I think in terms of educational system and the incentives of teachers, it's actually going to work out okay because teachers will remain in charge in the classroom, but hopefully they will value this much more effective kind of homework assignment turned into a whole conversational experience. And that'll kind of speed the development. What I worry about in the education space is there's no money there. And so when I talk to venture capitalists about this vision for education, the first thing they say to me is, well, there's no money there. So the profit motive that's going to drive, let's say, the technology for self-driving vehicles, I'm not worried about capitalism taking care of that happening once the technology is here. But I do worry about the incentive structure of for-profit companies in the education space. So I think there's something we can do about it. Governments can step in and identify areas where there's something which is of great societal value and where the usual free enterprise system is not necessarily going to take care of it, and the government can take care of it. But I think it's going to take that kind of decision-making by leaders to really make it happen.
Yeah, that's interesting. I think that's changed from time to time, how much of a market there is for using AI in education. There was a time, when there was just a boom, and then we're apparently not in one, according to your venture capitalist
According to my friends,
person. But I wonder, how do you imagine that a language model would be able to? So you gave the example of asking ChatGPT about what would be a good hint that doesn't give an answer away to a student. As students are learning new skills, depending upon where they're at on their trajectory of mastery, the appropriate level of scaffolding would change.
Yes.
How would a language model be able to do that? Or would that require a different kind of intelligence interacting with the language model, which would suggest that AI shouldn't be all about these language models, but they may be services that are used alongside other, so is it this replaces all of the rest of AI versus, if there are other parts of AI we still need?
Well, there's certainly parts of AI and computer science more broadly that we need. And this recent ability to add plugins like calculators and so forth is really a recognition of that. And so that said, I think the answer to your question is still, it's an open question. So an alternative to bringing in a different kind of system to blend it with the language model is to follow the kind of track that we were talking about a moment ago about personalization and giving it a 100-page document, which is your personal history. Well, that could be the personal history of the student. That could be actually the log of everything the student has done since they were 5 years old, working with this personal teaching assistant. And if that is the 100-page book that we give to the system before we ask it what would be a good hint for this student who just gave this wrong answer to the question, I think it's an open question of how well the language models will be able to accommodate and handle that personalization in that fashion. It may be that we can do better if we bring in other techniques as well. But you are raising an important point. AI does not equal large language models. There's a whole lot of other amazing stuff going on. Computer vision, which has nothing to do with language. Shouldn't say that. Computer vision, which sounds very different from language, is an amazing exploding field too. There's so much going on in general. It's just that, honestly, in the last 3 years, the big explosion has been in the large language models. And so we're not paying as much attention as before to these other aspects. But again, looking forward the next 5 years, doesn't it seem inevitable that we're going to have not just large language models, but large models that do language and vision and listening to ambient sounds in the environment and, controlling devices. So
you mentioned this 100-page book. To what extent do you think the idea of how you curate which text goes into that 100-page book is going to be a difficult problem that requires insight and creativity versus just, whatever? Because the way you described it for me, if I was going to have my personal assistant, it seemed like, let's just grab all the text you can, it's like all the stuff that's easy. My personal assistant, my support staff person hasn't read all of my papers, and I don't think that would be very usul for that person to know about my research, to be my admin.
this assistant may help you in new ways.
So some people are actually arguing. So I would consider the crafting of that 100-page book to be within the realm of shoot, why is that term prompt engineering?
Yes.
Some people saying with GPT-4 and maybe eventually GPT-5, prompt engineering as a field is going to be much less important because the models are so good anyway. So where do you fall on that spectrum? Do you think that there will continue to be a lot of specialized knowledge going into the curation of those 100-page books? Or do you think it will become so easy to just throw in whatever text one can scrape together that without any kind of insight into what's happening with that data, somebody could actually use the technology to build things that no one with that level of expertise would have been able to do in the past?
So that's another great question. And honestly, it's another one of the open questions for us to find out what the answer turns out to be. I'm optimistic, not for the coming year, but for the years after that, about it being easier than we were thinking to curate that document collection. Prompt engineering right now is really critical because these systems are highly sensitive to how you phrase the question and what information you provide along with your question and so forth. But two trends that I see, one is, I mentioned the 100-page book, but actually by next year, it'll be a 1,000-page book probably, right? So you'll be able to give more and more. Now, what should it attend to? What should it focus its attention on? Well, part of the magic of what makes these systems really effective is that they do have a mechanism that is learned along with the rest of the model that decides which of this huge context it should attend to the attention mechanism. At what point in its articulation of the answer. And I've been, and I think many people have been surprised at how effective that kind of technical attention mechanism is. And that gives me some optimism that we're going to be able to build systems that use that kind of attention mechanism to get at a lot of the problem that you're raising. In fact, I wouldn't be surprised if in some future version of these systems, you might be able to explicitly say to the system, you know, when, for example, in building a computer tutor, you might say, when the student fails a multiplication question, go back and make sure they can actually add correctly, because that's kind of a prerequisite. And so those kind of attend to this, if this happens, attend to that, and check out in the history that's been going on. Yeah, I mean, the other component of this is the current language models don't really have a memory. They have a current state, which is huge, but, and they have that context, but they don't have an external memory to remember everything. And people are now building systems where, again, another plugin is simply write to a file or search a file for this keyword and retrieve what's on that line. So we're at a very kind of early point in the development of this, but I think the idea of these plugins and being able to attach different computational capabilities to the models, yet still interact in natural language to get at them, is going to make, is going to be responsible for a lot of advance. That's kind of unpredictable to say what it'll actually, what those advances will exactly be.
I think your example of the going back to, okay, they didn't know this, so now I think that the right strategy is to see, do they have the foundation for that knowledge? I really like that as an example to think about the capabilities of how chatbots can learn to be conversational partners, because you could imagine that there may be tutoring dialogues that that could be in the corpus of things that these models are trained on, where it might have observed somebody taking that strategy. And so you could imagine that it might be able to learn that strategy from the examples that it had seen. But my question to you would be, where does the abstraction come from? So you might know they said this and then they, you know, said this other thing. And underneath it all, and as somebody who understands the concepts, you would see the abstraction. You know, I went to a foundational concept, but how did that abstraction take place? And I think what makes it harder to learn from a conversation than, say, from a narrative text, the logic that's underlying it, is because so much is implicit in the task when you have a conversation as opposed to a narrative. So how do you think that abstraction can take place? Because as I watch students of mine who are working with large language models, especially right now, I would say in a project that two of my students are doing, learning how to translate code between languages. It's the abstraction and the hierarchy that are really hard to learn. It's learning sequences, but it never really learns that abstraction and the strategy aspect of how you write code. So it sounds though, well, okay, so, and they're not working with GPT-4. You might say, oh, it seems like GPT-4 is going to be better at that. But where do you actually stand on that idea of learning implicit abstraction and strategy from examples of conversational behavior with any of these large language models?
I love that problem. It's, again, that's a future work problem. It would be, your question though makes me wonder, are the things that are hard to teach people the same as the things that are hard to teach LLMs? Right? So you talk about, well, how would this abstraction come about? And could an expert teacher even tell the system, tell GPT, GPT-7 or whatever. Uh, could even teach it that this is the way to think about the problem. It makes you wonder, are the things that are easy and difficult to teach people the same as the things that are going to be easy and difficult to teach these systems?
Yeah, I think that's a great question. Although I think we know from other genres of machine learning that learning from conversational data is actually much harder than learning from narrative text. So that isn't a machine learning versus
Right.
human issue. But
I will say the promise of that, if we could learn from conversations, every conversation is kind of automatically a labeled training example, right? If we discuss a problem, we come to some conclusion. Yeah. That conclusion is kind of a label for, gee, we could have had a much shorter conversation if we had thought about that first and just said it. And so when you think about where is good labeled data about reasoning processes and problem solving going to come from, if there are 100 million users already of ChatGPT, there are a lot of conversations out there. Even if the conversational data is only 1/10 as easy to learn, to machine learn from as labeled data, we might make it up in volume.
Yeah, well, that's a good question. But I think it raises, now that since we're talking about societal implications, both positive and negative, and we brought the curation issue up, do we trust the bulk of the data that the agents are learning from about how conversational interactions should go?
I guess it's like reversion to the mean, right? It's gonna be of average competence. And
yeah, I'm not even talking about competence. I'm going more into the direction of some of the fears around AI are in bias,
right.
You know, and other kinds of just unsavory behavior, which is rampant on the web.
Rampant on the web, and which, you know, the reason that Microsoft sat on Bing GPT for months and months was because they didn't want to release them until they had some better handling of these kind of issues of what it would say, not only bias, but, you know, what kind of questions it would answer. You know, questions like, how can I create the most deaths with just $1? You don't want it to really answer that question, do you?
No.
And I think that work has come a long way. It has a long way to go. One thing I found very interesting is OpenAI has now made available an API to their censoring system. So if you have your own large language model, you can actually pass its output through the OpenAI censor to see whether it would pass. I think there's already a bunch of research on how to, I'll use the word censor, because even though there's probably a more politically correct word, that's really what we're talking about. We're talking about censoring what these systems can say and what topics they can discuss. I think we're going to see an explosion of research. We already are, but we'll see even more of research on this kind of censoring, and I really mean that kind of a positive way for society. And by the way, one of the comments I've heard about US-China competition is China will have a problem with these models because they only want the models to say things that are according to the party line. But all this research we're doing on how to censor these systems is honestly is going to just solve, you know, much of that problem, so that China won't really have that problem any more than we have the problem of censoring these systems. So I do worry about that. I do worry. I think the most immediate question, worry, concern is deep fakes, impersonation. I know that with an election coming up in the next year, there are a lot of people in DC in the government who are specifically concerned about what are the possible implications for the election. Are there any precautions we can take? One of the ideas that I like and that I know some people in the US government are looking at is to create an organization that's analogous to what we have for cyber attacks. We have a thing called CERT. It's a non-government organization, happens to be here at Carnegie Mellon in the Software Engineering Institute. But its job is twofold. One, whenever there's a cyber attack that should be advertised, a threat, a virus, it posts it. So it keeps a current list of all of the threats. And second, it captures and disseminates best practices. So one idea is, even if we don't know what's going to happen, there's enough uncertainty that maybe we should stand up an organization like that, but for AI. And you can imagine it could have a list of, events that you should know about. Here's a widely circulated deep fake video. Here's here's the system that inadvertently leaks information about training data, and also could capture and disseminate best practices. So those sorts of things, I think, are good moves for us to take now, especially given the uncertainty that we have.
That seems very wise. I guess I'm realizing there may be some questions in the chat.
Oh, okay.
And so I know that we have Nicole out there who might be able to help to facilitate. Nicole, do you want to bring up some questions as you see them?
Sure, there have been a bunch. There's been a lot of good conversation in the chat so far. Let me go back toward the top a little bit here. So Jack asked early on, to what extent are large language models of intentionality learned from dialogues in fiction and interviews?
Great question. We don't know the answer, although because we don't know exactly what data OpenAI, for example, or Google, for example, trained their most recent models on. They consider that, I think, one of their secret, part of their secret sauce. So we don't really know. However, if you just take a random sample of the web, most of it's nonfiction. Although I will tell you, there are sweet spots where it knows everything about certain things. So one of my students, Shui Wu, has been looking at using these models like GPT-4 to play games like Minecraft. And it appears that GPT-4 already knows how to play Minecraft. I mean, it can tell you what move to make next if you want to construct a particular kind of structure.
I sometimes wonder what that means about how we interact with these kinds of environments like Minecraft. Is it so formulaic that it's possible for a computer to learn how to do it? And so, or is it being creative? I don't know. What do you think is, where would you place this being able to do something in Minecraft on that spectrum?
I'm not a big Minecraft player myself, but I know kids who are, and they like to go to these sites where people discuss how to do things. So there are these discussion forums where people trade, ideas and strategies that they discovered work. So I presume that's why GPT-4 is so good at playing Minecraft. It probably read those.
That's true. I'm not much of a gamer, but I have noticed that my husband spends a lot of time looking at those websites. What's the next question, Nicole?
Do you think that ChatGPT et al. Could be taught mathematics, including calculus, linear algebra, etc., at a level of a math bachelor's degree? The real question is, by using textbooks, could the AI learn to the level of a college graduate in STEM?
It's a great experiment to run. When we learn, by the way, I did ask GPT to teach me linear algebra, which I haven't already know, so I was checking it out. It did a decent job, it assumed I knew what a determinant was already when it was teaching me how to invert a matrix. It's a little bit out of sequence. But then I asked it to teach me quantum physics, which kind of worked. It told me the 5 qualitative things like superposition and the uncertainty principle and stuff like that. Then I told it to please get more mathematical and more precise. And it did. It gave me Schrodinger's equation, but it didn't define one of the variables. So it's not quite there. But the idea of reading a book and understanding it at that level is very interesting. I think that's an example of the kind of research that we need to do on these systems, right? And to what degree, the generic question there is, to what degree can these systems, if we give them something to read, really then behave as though they understand what we gave them to read? And where are the limits to that? You know, for example, can they now correctly answer any of the factual questions that were in what we gave? Number 2, if they can they actually put those facts together to reason their way through to solutions to problems? And so I think, you know, trying to understand those capabilities, where the limits are, and then use those limits to figure out what to do about them, is a really interesting research direction.
Yeah, I think those are great examples though, because they show the difference between teach me this topic and help me with this egg problem, right?
Yes.
You know, in terms of like, you know, where are we at in terms of these models being able to generate good pedagogy? It seems like from your examples that like, how do you actually teach this topic is way beyond the capability of where they stand. And yet there's fundamental knowledge on small pieces that could be leveraged. And so it suggests a way of using it that requires using it as a tool, learning what the affordances of this tool are, using it intentionally with your expertise as somebody who understands how to teach a big topic, using it, but not deferring to it in terms of like how that work could be done. It seems like that's where a lot of the interesting research it seems like what you're saying is that because I think that sometimes people get that they hear these examples like the egg example and immediately jump to that means that they could generate a textbook, right? You know, and so I think that there's some feeling out of where is that level at which we would interact with these tools. I think that there's a lot of thinking on the programming side. How do we use something like Copilot? Lots of people are playing around with that. I think there's still seem to still be good questions there. What is the next question, Nicole?
There are so many questions. I'm just trying to read through them all. It's an interesting one. How about other math systems? For example, Ethiopian math.
Oh, wow.
Yeah, that is a great question because Ethiopian, even as a language, well, you know, like the language of Ethiopia, which is not called Ethiopian,
So
it's still a low resource language. Even learning the language before you could absorb the materials to learn the math is a.
And there's a kind of related question which says large language models have been proven to be really good at lots of things like reasoning. But what about their performance in underrepresented languages? In what direction our research in that area should be directed to?
Yeah, it's a good question.
I should ask Carolyn that. She knows more about training on underrepresented languages.
But it raises a general question of, a lot of the demonstrations and capability are on things where we have a lot of data. But what about, but do we believe that we have a lot of data on all of the things that are important to be able to learn? So is there a match there, or is there kind of a misalignment sometimes between what we have convenient data for and what we probably need intelligence for?
And it goes beyond language. So I've been talking with some people in Japan who were asking themselves, well, should we be using GPT-4 or should Japan have its own Japanese version?
Mm-hmm.
And I don't know if GPT speaks Japanese or not. I know it speaks many languages, but they're not, their question is beyond that. It's really about the culture,
Right.
The cultural differences, not just the language differences. And so in those trillions of documents that have trained GPT, which come from the web, which is an international place, heavily dominated by the US, what about training on underrepresented, at that scale, cultures as well as language? And so that the common sense that these systems absorb become the common sense of one culture or another.
And what if it's not written? So I had the privilege of doing some field work in Kenya, where I got to talk to representatives from a variety of their tribes about their tribal practices that are not really written down. And so, would, so if it's not written down, then what would you do? Yeah, so that there are things that you can't learn from books, and so I wonder what would happen in that case. So we have only 5 more minutes left with Tom before he has to leave and we begin the mixer activity. Are there some questions that we can use our last precious moments with Tom to address?
I have one more I'll ask here. So considering LLMs and the language component, where should we look next in order to know which components, such as memory, reasoning, intentions, alignment, we have to add and blend for solving more tasks?
Oh, that's easy. I think we need to add them all. Really, seriously, like, how intelligent can a system be if it doesn't really have a memory? How intelligent can it be if it doesn't have the notion of a notion of goals? And maybe, to some degree it does, like it knows what problem you're trying to solve, but there's something I think more foundational that's missing there. So in AI, we have, 60 years of research on how to architect agents that have these variety of capabilities. And the amazing thing about these language models, they came out of nowhere, it felt like, and they just kind of outperform all the other stuff that we've tried, 99% of all the other stuff we've tried. And yet they're lacking these very fundamental capabilities. So I think it's a no-brainer that we want to incorporate those. That's why I'm so excited about this notion of plugins, because it starts to move us in the direction of building architectures for agents that can use kind of as the backbone these language models, but take advantage of all kinds of other great ideas and computations and algorithms that we have. Another thing I see along those same lines that makes me quite excited is research on building architectures where each subunit is itself a large language model. So there are systems out there like AutoGPT, where and others, but where imagine an architecture, you're trying to build an agent to do something like find you the best deal on what to buy out on the web. And you say cameras, for example. And one agent, it calls one agent that just has the responsibility of finding out what cameras are out there and what their specs are. You have another agent which has the job of reading the reviews and summarizing those reviews for you. It becomes an expert at that. You have another one that looks at different websites and see who's offering the best price. So the idea that we might have architectures for AI agents that where the subroutines or the subcomponents are themselves these kind of systems, and where the API between them is some kind of natural language exchange or structured language. I think it's very exciting. So these are some of the directions I think inevitably we're already starting to see, and they're going to be, I think, responsible for big advances in the next 3 to 5 years.
One more question.
On the note of quantum mechanics and computing, to what extent do you think the barrier to a true AGI being computing power?
Yeah, that is a good question. So if you talk to the OpenAI folks, they will show you scaling laws, plots of scaling laws that they believe empirically exist, although we don't have the explanation for why they exist, but they'll just show you how the capability of these systems over the last 5 years has grown, plotted against the complexity, the size, and the computational demands that it takes to train them. And they believe, based on that plot, that if you extrapolate it, we're going to have even more competent systems if we can get another factor of 10 on computation and training data. Maybe, I think, honestly, it might turn out, this is like the $64,000 or $64 trillion question. Is it going to play out that the pioneering advances here come from building bigger and therefore better models that only a handful of organizations can afford? Or is the open source community going to be able to out-innovate and find ways to build smaller models that are themselves really competent? One data point on that that's very interesting is Meta, Facebook, inadvertently leaked its llama model, after which it announced it was releasing its llama model. But then since that time, people at Stanford first took that and got GPT to generate some more training data. And for, they claim, under $1,000 or on the order of $1,000, they were able to train a better version of llama that they can run locally on reasonable computing. After that, somebody else built a system called Vicuna, including some people at CMU involved in that, that does even better than Alpaca, which was the Stanford version. So there is this kind of very interesting path where the open source community, if you want to call it that, is competing against these big models. Now, who's going to win? The big companies have big resources, but you think about how many researchers they have. Suppose that each big company hires up and gets 10,000 researchers, and there are half a dozen of those big companies, and now they have 60,000 researchers. That's small compared to the open source community if you add in all the universities. So universities and open source are going to have a couple of orders of magnitude more innovators than the large resourced organizations. And which one is going to, how the research landscape is going to advance in that case, very uncertain. So it really is one of the social scientific questions about how this whole field is going to evolve. It's going, and the outcome of that, the answer to that question is going to have a lot to do with how these things get deployed, whether there are a small number of companies that accumulate even more wealth, or whether the wealth gets distributed, it's going to have big implications.
Okay, well, I think we need to let Tom go. He had a plan, and we still have the mixer coming up, so hang on. But let's give a big round of applause to Tom, and thank you so much for spending your time. This was great.
Great conversation. Thank you very much.
Okay, so let me go ahead and share my screen again and move forward to the mixer event. And Tom is going to slip out. Thank you, Tom. I just want to first remind you once again that next week at this time, we will have the keynote talk by Roni Rosenfeld and the Ask Me Anything panel. So if you're interested in coming back, we'd love to have you for that. And I'd just like to encourage you all to think about the opportunities that are raised by the topics that we discussed today. And many of you out there, I noticed from looking at affiliations and expertise, are highly educated in the space of large language models, already doing work with them. Others might be interested in finding out how to move into this growth area that will ultimately open up new kinds of jobs that require possibly additional instruction. I just want to point out that one opportunity coming up, especially for those who are interested in gaining the foundational skills to be able to do programming in the data science area with large language models, might be interested in our certificate in computational data science foundations, which will launch in fall. And if you're interested in this, there's a URL here, bit.ly CMU CDS, that's Carnegie Mellon University Computational Data Science, if you're interested in getting more information about that. And now to prepare for the mixer, what I'd like you to do is think about your own response to the discussion today, especially all of the insightful comments by Tom, and think about how that may have challenged your thinking coming in or caused you to want to learn more in certain areas. And what I'd like to encourage you to do in preparation for the mixer is take a moment. I believe that Nicole will be pasting this URL into the chat. Go ahead and click on it. It's just going to ask you some questions about your reactions to today's discussion. Just really 2 questions in there to go ahead and answer. I'm going to ask Nicole actually to go ahead and stop the recording now, and I'm going to give you about 5 minutes to go ahead into that and type your reflections, and then we'll start the mixer activity.